So today we're here to discuss the topic of secure machine learning. And this is automated security best practices in ML. Just a little bit about myself. My name is Alejandro Saucedo. I'm engineering director at Cell Technologies, a deployment and monitoring for machine learning startup based in London. I'm the chief scientist at the Institute for Ethical AIs, which is a UK-based research center that focuses on developing frameworks for the responsible development, design, deployment, operation of machine learning systems, and I'm governing council member at large at the ACM. Just as a bit of a reminder, the resources for this talk are going to be in this repo, including the slides. So the repo is ethicalml/FML security, stands for flawed machine learning security. There was a lot of work exploring the acronym. So please do give it a star, and also if there's anything missing, do feel free to add anything relevant. To just provide some motivations for today's talk, the objective of this session is taking the premise that security is a very well-known topic in the software and DevOps space. So there's a lot of resources, a lot of topics, a lot of principles that provide some of the best practices in order to how to tackle reducing vulnerabilities within the software stack, right? However, when it comes to the machine learning ecosystem, there are a lot of really interesting resources that tell us how we could apply machine learning into security, stuff like malware detection, things like spam detection. But when it comes to best practices of how to bring in security into machine learning, there is not as well of a defined ecosystem. So we're going to be taking a similar approach that is taken in general software, which is basically to acknowledge the fact that it is impossible to make a system unhackable, right? And what we can achieve is to try to mitigate undesired outcomes through best practice, right? That's what you can aim to achieve. And with that same premise, we have to remember that even though we're going to be talking about a lot of technical solutions, ultimately the solutions will involve processes and people, right? And we know that when it comes to security, the biggest vulnerability touch points are actually process and people. So that's something that is going to be important to bear in mind. We're going to be taking this concept of MLSecOps, which is a growing topic, an emerging topic, which encompasses the intersection of DevOps, security operations, and machine learning operations. So it's taking the machine learning infrastructure with security as that first principle, right? And that's what we're going to be looking to flesh out in this session from a practical perspective. We're also going to be leveraging some of the resources that are out there in industry. There is this source and project called OWASP, which publishes every year this report called the OWASP Top 10. This is basically the most common vulnerabilities. So this is basically on web application security, right? So that's what the OWASP stands for. And these are things that you may be quite familiar with, especially if you have been working on Django, Flask, Fast API, making sure that you take into consideration things like broken access control, right? Making sure that you avoid things like SQL injections, making sure that you follow best practices and infrastructure design, right? So this is very specific to web development or just web services, but we're going to be referencing this back, and we're going to be able to see that by the end of this talk, we're going to have our very own OWASP Top 10 for machine learning with a one-to-one analogy between these ones that are very proven in industry and the concepts that we have been able to define in the machine learning space. And we're going to be covering the end-to-end machine learning lifecycle. This talk is not about machine learning deployment, machine learning productionization. So we're going to be swifting through a lot of concepts that are involved in the machine learning deployment side. But there are going to be resources that we're going to be linking at the end. If you're curious on what happens and what we did for each of these steps, how we converted our machine learning artifact into a fully fledged microservice, deployed in Kubernetes, that we were consuming requests, you can check the videos that are linked in the session. But we're going to be swifting through and doing a little bit of like hand waving for this stuff because we only have 25 minutes, so we can't really cover all of that. But in principle, just for you to have an intuition, what we're going to be doing is we're going to be taking a machine learning model artifact that has been trained by, say, a data scientist team or working with the data engineers, And we're going to be converting this machine learning model into a machine learning system, right? We're going to be deploying this model, this artifact, into a container that will be running in a Kubernetes cluster that we're going to be able to consume. Of course, this is just a use case. The principles that we're going to be covered will still abstract and apply to other of these areas. So let's start with the first step, deploying a machine learning model. Before we actually delve into that, we can see what are the different phases that go in the end-to-end MLOps lifecycle. So this is the LFAI, I guess, ecosystem that shows how you go from data cleaning to data validation, feature engineering, then you move into model training, model evaluation, and then you go into model deployment, monitoring, et cetera, et cetera. So if we were to ask the question of which are the points throughout the end-to-end MLOps lifecycle where we are at risk of security vulnerabilities, it would be only the red areas, right? So basically, every single step of the machine learning lifecycle is at risk of potentially having security vulnerabilities. So that's something that we have to take into consideration. That is not just going to be like a single tool or a single process that we can introduce, but it's going to be a series of. And as I mentioned, we're going to be delving into this from a practical perspective. What we're going to be doing is asking the question of what is bad practice? What does flawed machine learning look like? And what does flawed machine learning look like at each stage of the machine learning lifecycle? Of course, not covering every single one because we don't have enough time, but covering some things that will give you a bit of an intuition. This will include loading the models, so the actual model artifacts and the security considerations in that specific point, undesired access to a machine learning model, dependencies and the supply chain of potential vulnerabilities, code vulnerabilities, model or runtime images and code, as well as some honorable mentions on infrastructure. So the first part is Pickles. So who here has used a pickle to export their machine learning model at one point in their life? So let's see some show of hands. Okay, everybody, right? So, data scientists, machine learning engineers, I mean, I wouldn't go to say that we all love pickles, because I don't think that's the case, but we all use pickles. And we've all heard, you shouldn't use pickles because they're a security vulnerability. We've all heard that. But why, right? Like, what's actually the vulnerabilities that can be exploited with pickles? Let's have a look. So first of all, if we want to just take a machine learning model, let's start with the hello world of machine learning, the iris classifier. Zoom in. Perfect. So let's start with the hello world of machine learning, the iris classifier. So if we take basically the iris data set and just take a logistic regression model, train it with that data set, basically now we have a trained model locally, which we can run prediction against. We can then put that model into a Google bucket, right? That's how we are going to be able to put it in our production environment, in our container. That's how it's going to be downloaded. If we actually have a look at what's inside of that pickle, we can see that in the pickle, even though it's a lot of gibberish, we can see there are some things we can understand. This is telling that it needs the module from scikit-learn on the logistic submodule. It wants to use the logistic regression class, and it wants to initialize it with this input. Right, so that's basically what we can see from our specific model. So we can now upload it into our bucket and now deploy it, which in this case will be with our Seldon Core component, which again, hand wavy, but you can delve into this, you can try it yourself. We can now see that the model is running, and we can consume that model as we did in the local environment, but instead we can consume it as a service, right? So we're sending that input, we're receiving a prediction, right? So in this case, the prediction is a one-hot vector, or probabilities, and it says that this is the class number 2, right? But now if we want to ask the question of, well, what happens when we try to find the exploits of that pickle? We can first try by just loading that pickle. We can try running a prediction. It still works, right, as we expect. But now what if we actually meddle with the functions that Python uses to be able to know what's inside of a pickle and how to read a pickle? That is actually this function called the reduce function. Here we're going to be replacing it. Instead of saying, hey, you need to use this logistic regression module with this logistic regression class, we're going to basically say, no, you actually want to use the os.system module, and we want to just pass this base64 encoded string, which basically is just a command that runs env, so it copies all of the Kubernetes secrets, well, in this case, all of the environment parameters into a pond.txt file, right? So that's all it does. But you can see that here you can run anything. You can send an email. You can, like, the kubectl will get secrets, et cetera, right? So we inject that specific, we put that function. We inject that specific function into our class. And then when we actually dump it and we look at the pickle, we can see that here, because it was base64, we can see that the env to pond.txt is there, right? So that's actually what we now have in our pickle. So it's now a poisoned pickle. Let's call it poisoned pickles, right? That's a new term of security vulnerabilities in machine learning. We deploy our unsafe model in this case, and when we actually look inside of the pod, we can see that that pond.txt was created, right? So it actually ran, it actually is being served, but when we look inside of the container, we see that that code was actually executed. We can reproduce it locally. If we actually load our unsafe model, we can see that that file got created locally, right? So in a simple sort of like, set of, code executions, we were able to see some of the challenges of access to the model artifact. Now, the challenge is actually a lot of the machine learning libraries that are popular in the machine learning space use Pickles, right? This is not just scikit-learn's, joblib framework, but also some of the, I guess, more popular deep learning frameworks like PyTorch or even TensorFlow or Keras would use Pickle in some stage of their sort of load and unload of models. And the question here is, well, should we create some sort of like, scanning, tooling that would allow us to actually just like open up the Pickles and see if there is any malicious code? Well, the actual answer is something that we can infer from other, I guess, subfields of software, which is basically no, right? When it comes to loading arbitrary code, being a pickle or be it a repo or a Docker image, it is very much a trust or discard mechanism, right? If you cannot ensure that you have the ability to build kind of like trust at the, I guess, CI pipelines or the steps in which you are, interacting with this creation of artifacts, it is a trust or discard. However, there is an even extra step, which is if you can use some other encodings and serialization methods like Onyx, like PYML, other serialization methods that don't require you to actually dump that binary, then that would actually add a plus, right? Doesn't mean that you're going to be able to do that all the time, but it's just to make sure that there is that conscious assessment from that perspective. Now let's move to the next part. We've seen what is the challenge of access to the model artifact. Now let's see the challenge of access to the model as a, in this case, black box access to the model. What that means is to be able to have unrestricted ability to be able to perform inference on a model as a black box. What you can do with this, and some examples that we have seen is, using things like building adversarial examples. These are basically examples that allow you to trick a classifier whilst also tricking the human that may look at that image input. So here you can see very intuitively the image of a horse that would have normally been predicted as a horse, but with some statistical noise that is added, it's now predicted as a dog. That truck as an automobile and that dog as a horse. Right, so it's just basically statistical noise that it's not possible to really see by just the naked eye. And for adversarial examples, we fortunately have a machine learning library called Alibi Detect, which you can try out. Again, we have some examples that allow you to build not just adversarial examples, but also adversarial detectors, which basically means that you're able to introduce an extra component within your stack that would allow you to detect a potential, well, with a probability scale, how likely an input may be a adversarial example. And here you can actually see different techniques that would allow you to generate some of the specific adversarial examples and perform some adversarial attacks, as well as trying to reduce some of the statistical noise for that. But that gives you some very intuitive idea of some of the challenges that you may be facing with unrestricted black box model access to your models. However, it's important to also assess the fact that not always you have to introduce something as advanced like an adversarial detector, right? Sometimes you can actually just introduce role-based access control. Maybe not everybody should have access to that model. And this is also important not just for the context of adversarial detection, but also for things like machine learning explainability. we have actually seen that there are a lot of fields or a lot of use cases where machine learning explainability algorithms are important. But then there's also the question of like, who should have access to those explanations, and to what extent that should be sort of restricted. The second type of access to a model would be white box model access to that model. That means access to the actual model weights, to the artifact itself. And there are some interesting risks that are involved with that. This is actually a very interesting research paper that showcases how it is possible to extract training data, or at least, in some cases, some training data, and potentially, sensitive data, from a, in this case, large language model, right? So, of course, when it comes to large language models, there are some risks, but there are simpler machine learning models that actually require carrying the entire training data to perform inference, right? So there are considerations to take into account that it's not just about putting the model in production and then that's it. There are privacy considerations, there are security considerations that need to be taken into account. Of course, proportionate to the risk of the use case, right? Like if you're just trying to build a prototype, the amount of red tape is not going to be the same as trying to deploy something that is potentially going to have generational impact on an individual, right? So it has to be proportionate. Now the next step, right? So we've talked about the code artifact, the components, now the code itself, right? Machine learning models and machine learning runtimes come with code, right? So that's not different to the normal software that we build as practitioners. And the challenge of this is that there are cases where we have found vulnerabilities introduced by some of the suboptimal practices in code paths within libraries. I mean, I don't know if some of you may have been affected. I know that I do remember when the PyYAML from unsafe came in, and everybody was kind of like panicking, trying to first get on the back of the PyYAML repository, and then once it got upgraded, actually like propagated upstream within the dependencies. But it's important to make sure that where possible, machine learning runtimes mitigate those risks. So we're going to be covering some of the tools that are for that. So let's actually talk a little bit about some of the tools that you can use. Fortunately, there are some closed source tools that things like GitHub provide you, which are kind of like automated within your pipelines. But you can also use tools like Bandit, which allow you to actually perform some common scans within your code base and point out some high, medium, and low potential severities of vulnerabilities that are involved. And we're going to talk a little bit about more in practice of what you can do to actually take it forward. Just as a disclaimer, remember that Jupyter Notebooks, if they grow to a certain amount, they can also become, introduce risks that are proportionate to also code that is deployed in production. Now, the next point is on dependencies, right? I mean, anyone that has like maintained a library for more than perhaps like a couple of months has had a situation where it all works on Friday, come back on Monday, and then stuff is broken, unit tests are broken, you see why, and it's because like 7th level dependency that was unpinned got updated and broke everything upstream, right? And there are challenges that, not just involve potential code breakages, but when there's actually vulnerable or malicious code that is introduced downstream. And this is not just me trying to bring in panic of something that may never happen. We actually saw that just recently last week. There was a very popular Python library that actually got hijacked, and there was a malicious code that was injected. It was about I think downloading and sending AWS secrets to a malicious source. So it's very important that we take the concept of supply chain security very seriously, because the general software world is taking it already very seriously. And there are some collaborations that we have done with projects like MLflow, where we have done integrations of a runtime server. ML server is also an open source runtime to try to avoid doing things like dynamic dependency download on container run, right? So that's something that you really don't want to have every time that you push your model to production, to download all of the dependencies, right? Because you're introducing just more unnecessary risks. Now let's move into that example vulnerability scans. So there are some really interesting ways of visualizing this. Of course, you can remember how whenever you look at the dependencies of Python, you may pin all of your first level dependencies, but if the second level package doesn't pin them, that's it, right? That means that you're going to have some breakages. Of course, you can actually try to do some workarounds, doing a pip freeze into a requirements freeze.txt and just have all of the dependencies on your environment. But there are better practices to do this, similar to the poetry project, which generates a poetry.log file. And this basically allows you to just keep track of all of the first, second, plus level dependencies of your code. You can also use tools like safety checks that allow you to actually perform scans into your dependencies to identify if there are vulnerabilities with the current versions of the dependencies that you're running against. And this is important as you want to make sure that you keep that updated. And finally, you can use projects like piprot, which tell you basically like dependency bot, what are the dependencies that may be deprecated or old that you should be updating and looking at that. So there are a lot of resources that you can actually use. And it is similar when it comes to actually building your components, right? Whenever you actually build your images, you have some value and benefits of ensuring that you have everything kind of like frozen into a single sort of artifact. But at the same time, it's important that you also perform security scans. And there are great libraries like Trivy that allow you to do all of those. So those are some of the high-level, flawed machine learning examples that I wanted to cover in this case. There are some honorable mentions. This is not a Kubernetes conference, it's a Python conference, so I don't want to delve too much into the Kubernetes infrastructure or just general infrastructure, but there are some nuanced best practices when it comes to encrypted data in transit, at rest, introducing authentication, authorization, not just in the context of web services, but also machine learning systems, right? Remember that when you go from a machine learning model into production, you are actually converting that machine learning model into a machine learning system, right? And you need to take into consideration the complexities that are involved within that. So if we actually look at the OWASP top 10 vulnerabilities that we introduced at the beginning of the talk, we actually covered a equivalent top 10 for machine learning. So this could be like our OMLSP equivalent or our OpenFML equivalent, or however you want to call it. But here you can see that for broken access control, we talked about black box access to model endpoints, cryptographic failure, access to the white box model access to the models, injection, artifact exploits, insecure design, that's at the infrastructure level, security misconfigurations, again, at the configuration of the infrastructure, et cetera, et cetera. Now, I wanted to make sure that we cover this session, and I don't just be like I don't just come here and say like everything is terrible, everything is insecure. Thank you very much, bye. But instead to actually say, okay, well, let's collaborate on a way to define how to actually tackle this as best practices. And we've created what is a base template that would allow you to actually perform some of those things. And this is basically a cookie cutter template. It's just basically an interactive way of creating your base project for machine learning engineers. So this is not specifically for data scientists, but it's for the machine learning engineers that are going to be creating those automation pipelines that are going to create, package, and deploy the models. This basically creates a project with the specific parameters like a project name, the author, etc. And it gives you some base things to work with, like a poetry configuration for that runtime. It would use a runtime server, ML server, which basically runs on Fast API. It allows you to actually test with some local artifacts, which basically you can run as a service, and with all of the utilities to be able to interact with it, right? Like send requests, but also perform code scans, perform dependency scans, perform local, old dependencies. So you can actually check it out. You can see all of the features that are currently in place, but also some of the upcoming features that we're looking to put. So also the deployment, productionization, and hardening. And so just as a kind of like reminder, today we covered some intuition of the MLOps lifecycle, right? How practitioners convert training data into artifacts, then how automation pipelines can deploy those artifacts into services, how you can add some things like adversarial detectors, as well as infrastructure configurations, so that you make sure that in your end-to-end lifecycle of your machine learning pipelines, you provide the best practices through human and touch points that align with what is required. And also take into consideration the different personas, right? The data scientists that create the artifacts, the machine learning engineers that create the pipelines, and the DevOps engineers that actually handle and manage the entire infrastructure. So As I mentioned, there's a lot of resources that we kind of like, swift through, but if you're interested, there are 1-hour talks on CI/CD for production machine learning, production monitoring patterns, of accelerating ML, et cetera, et cetera. And the resources for the talk, you can find them in the ethical ML/FML security repo. With that, thank you everybody for your time, and I look forward to continue exploring this topic further. Thank you very much. All right, we managed. That's great.
All right, Alejandro, that was a perfect timing and a great presentation. We have now 2 questions in Slido, and please, if you want to add any, just scan the QR code, else I will pass the microphone, old style. So first question, why should I care about vulnerabilities if I'm working inside the VPN?
I think that's a bit trolling, I would assume. Yeah, well, so I think the challenge is that a VPN, the only thing that it does is it blocks out potential external I guess communication. But there are extra nuanced questions that need to be coming into that, right? The first question that comes to my mind is, I mean, if you're going to run an installation of your Python dependencies, they have to be fetched from somewhere, right? At some point. Unless you have 0 dependencies and you wrote every single possible, I guess, nuance, and you're doing machine learning, I don't know, with C++ or Fortran, and you just literally built everything. I expect that you download some dependencies at some point. So you will already be exposed at some stage of the MLOps pipeline, be it at the stage where you're actually downloading those dependencies for your runtime, at the stage that you're building the images, at the stage that you're even fetching the data, and then also the challenges that may be involved in suboptimal best practices within your organization. Having a VPN doesn't mean that perhaps someone didn't just bring a USB. I mean, I don't know. I don't want to be also like super paranoid on those things. I would say more about like just dependency scanning, the more reasonable areas, right? It's like you're going to download those dependencies. You still need to, at least at some point, be able to scan for potential vulnerabilities and suboptimal code paths. So yeah, that would be, I guess, an initial thought for that. Yeah.
All right, then next question, we have differential privacy can be used to mitigate model inversion attacks, but it could decrease the accuracy of the model. What's your opinion on differential privacy? Do you know alternatives to avoid model inversion attacks?
Right. Okay. Well, so I mean, I think when it comes to differential privacy, again, like the field contains a lot of areas where it's kind of like in the exploration, right? There's things like homomorphic encryption, right? The ability to be able to make sure that you send all the data and you perform inference on encrypted data that doesn't expose anything, right? But when it comes to techniques, this is one of the reasons why I wanted to emphasize so much that it really isn't about the tools. It really isn't about the algorithms. It really is about the use case, the relevance for the risks that are involved throughout the different touch points of that particular project or system, right? And again, the relevance of things like privacy-preserving ML, there could be situations that no doubt there would be value for those, but at the same time, similar to the example that we covered on adversarial detection, most cases you can avoid some of those risks with role-based access control, right? And it's similar when it comes to access to data, restricted access to both the models, the artifacts, the endpoints, the I guess training pipelines, et cetera, et cetera. So yeah, I mean, I would emphasize that at least at this stage, we are still trying to figure out the rules of the playing field. It is more about what are the high-level areas, the tools come second. But absolutely, there's definitely a lot of relevance for privacy-preserving ML at a lot of the stages of the MLOps lifecycle. And I would be super interested to find if there are some that could be introduced in some of these templates that we are creating. So yeah, that would be some thoughts on that.
All right, we have time for one last quick question. It's the gossipy one. What do you use to save models? Which libraries do you use for exporting and saving models?
Yeah, so we use Onyx, particularly because it introduces a lot of optimizations. You can perform like quantization of your models, as well as being able to run them in like optimized runtimes like Triton. So right now I showed how to deploy a Python model in a Python runtime, but with this ecosystem, you can also deploy on a Triton runtime, or on a TF serving runtime, or on a torch serve runtime. So I mean, again, it really depends on what, but yeah, I mean, I would recommend checking out Onyx. There is a lot of value that you get from that. And even though it's a little bit, I guess, rough around the edges when it comes to like getting started with some of those tools, once you actually build some pipelines that perform this in an automated way, you have much more robust ways of using this safer exporting mechanisms.
All right, there's no more time for questions. If you have anything else, maybe you can catch him outside. That was Alejandro on machine learning security.